Okay, today we are going to calculate the total volume in milliliters. For this, if you know, right here it says when the flow rate and the infusion time are already given to you, the volume infused over a given period of time can be calculated so that you can monitor the IV properly. So what that means is if you know the flow rate and how long the infusion time, then you can calculate the total number of milliliters needed to be infused. I did find this. This might help you with infusion time and total volume. This is just the pyramid, so you've got the volume on top, and the volume is calculated in milliliters. At the bottom you have two things. You have the rate and the time. The rate is your flow rate in milliliters an hour, and time is going to be measured in hours. The way you would work this, if you were talking about just infusion time, which we are not, but if we were, that means you would say, okay, I'm looking for the infusion time. Okay, so what I'm going to do is I'm going to cover it up, and I can't cover it up, but I'm looking for this. So what does that tell me to do? Well, what's left? The volume divided by, because this is divided by, the volume divided by the flow rate, or milliliter divided by milliliters per hour. Now, we aren't working with, I have to fix that now. We aren't working with infusion time. I just wanted to show you. Okay. We're working with total volume. So we're looking for the total volume on the top. So we're looking for this one. So what's it tell us to do? It just tells us to multiply the flow rate times the time. So the formulas for this would be milliliters equals the flow rate, so abbreviated flow rate times the hours. Personally, I prefer to think of it in terms of units, and if I was talking about units, well, I'm going to take my milliliters per hour, because that's how many milliliters I get every hour, times however many hours that I have. Actually, let me change this to a T, flow rate and time. And below that, it's how I think about it in with the units. So I've got a couple problems. For these, so it just says, whoops, sorry, I meant to move it. It says determine the volume. And what we have is D5RL set at 75 milliliters an hour for 8 hours. Okay, so we're looking for the total volume, and that's in milliliters. So we're looking for milliliters, and my brain likes to see it with the flow rate of milliliters per hour times the hours. So to write it out, the milliliter per hour is 75 milliliters per hour times 8 hours. And those units would cancel. And then you just say 75 times 8, 600. And the unit left is milliliter. I did want to show it in dimensional analysis. Okay, so for dimensional analysis, this time we're not looking for milliliters per hour, we're just looking for milliliters. So our first fraction that's just guiding our problem is milliliters over 1. So you're just going to go into your problem, you're going to find something that says milliliter. Okay, well up here I've got 45 milliliters. Or sorry, 75. 75 milliliters. Okay, and its best friend is that 1 hour. So I have 1 hour. Okay, but I don't want hours. I have hours, but I just want a 1 at the bottom. So I'm going to get rid of my hours. So I go back up to my problem, and the only thing I have left is 8 hours. And that's the only thing left, so you put it over 1. You can check yourself. Yes, I started with milliliters, and I ended with a 1. The hours cancel, and you still get 600 milliliters. Okay. So for this one, have an order of 50 milliliters per hour of normal saline for 12 hours. How many milliliters will be needed for the IV? Okay, so I'm doing, I'm looking for the total volume, the milliliters. So with the formula, it would be the flow rate of 50 milliliters per hour times the time in hours, which is 12 hours. And you can see how they cancel. And then 50 times 12 is 600 again. Crazy. Okay. Just to show you dimensional analysis, you take the milliliters over 1. Find something that says milliliter. So I've got 50. Let's change the color actually. So I've got 50 milliliters. And its best friend is 1 hour. But we don't want hours. And the only thing else we have is 12 hours. And you still get the 600. Okay. Last problem. I just wanted to talk about one where it's given in minutes. So again, I want the total volume. And I have an antibiotic solution infused over 2 hours, 30 minutes at 100 milliliters an hour. So we're going to use the same formula of the flow rate, milliliters an hour, times the time in hours. But notice that we have 2 hours and 30 minutes. Certain amounts of time it would be helpful to just memorize. Most people are very comfortable with knowing that 2 hours and 30 minutes is also 2.5 or 2.5 hours. The other ones that would help to be comfortable with are 2 hours and 15 minutes. And one way to think about it is, well, 15 minutes is a quarter of an hour, right? So 2 hours and 15 minutes is 2.25, 2 hours and a quarter. And then the other one that's helpful to memorize is the 45 minutes, which would be, oops, not 0. Let me change that. I was thinking, I keep forgetting to put it 2 hours and 75, or sorry, 2.75 hours. Now for our problem, we're only working with the 2 hours and 30 minutes at 2.5 hours. I just wanted to go over these. Let's see, where am I? So I'm doing milliliters, so milliliter equals the flow rate in milliliters an hour. So 100 milliliters per hour times how many hours? 2.5 hours. And I get 250 milliliters. If you did want to see it with dimensional analysis, it's milliliter over 1. You're looking for milliliters, and that's in my flow rate. It's 100 milliliters per 1 hour. And we have 2 hours and 30 minutes, which is 2.5 hours. Or 1. And you should still get the 250 milliliters. Okay, so that's a video on total volume. I hope it helps. Bye.